Good afternoon. The next 30 minutes, we would like to propose to you a game plan to validate the success of your innovation. So today we're going to talk about the innovation process at Bol.com. And how did we experience a typical innovation process? So first you start with a problem or an opportunity. And then next up, we create a business case. So we think about a solution. And of course, we would like to make the business case as big as possible, because the bigger the business case, the higher the chance that we're actually going to build it. And after your ID survived all the rounds of Agile at Scale, then IT is finally going to build it. In general, that takes quite some time. And then we do some testing, some functional testing to see if it does what it should. And once it's tested, we deploy. And of course, do not forget that we are celebrating our success because we build a new innovation.
Yeah, so as Christianne already says, big business cases, otherwise we don't make it through Agile at Scale. And big business cases should mean big earnings. And I mean, if we have really big earnings, we should be able to do a lot of cool stuff, right? So why aren't we doing that yet? So why aren't we already delivering packages with drones? I mean, we should have the funding to actually do that. Why aren't we starting up a spin-off and build spaceships and go to Mars? I mean, we should have the funding to do that with all those big earnings from the business cases. And last time I checked, I also still don't have a pool of money in my garage. And I mean, we should have the funding to do that. So why don't we do that? Are we missing something here in this innovation funnel maybe? Or are people just draining our bank accounts? Well, we think that we sometimes forget to ask a couple of crucial questions. So for example, do we always ask ourselves the question whether we actually made our business case? Do we actually always check whether we solved the problem? And how do we actually know if we solved that problem? Can we sort of measure that somehow? I also we don't always ask ourselves the question or we don't always test multiple solutions. Often we just think of one solution, or at least we only build one solution and we test that one. And lastly, if we fail, could we have failed faster? Could we have found out way earlier that this idea was a terrible idea? So my name is Botman. I'm a data scientist within logistics.
And I'm Christianne Wisse. I'm a data scientist within logistics as well. And as data scientists, we try to find an answer on all the questions that Loek just asked. And therefore, we tend to use an innovation funnel that helps us answering all these questions. And why do we need this innovation funnel? So why do we need something different? And that's because there are 3 benefits of this new innovation funnel. So firstly, we can test multiple designs. Secondly, we can validate even before going to production, but also after we go to production. And finally, we have the possibility to fail fast. So not fail after an innovation is live, but even before that.
Sounds promising. So let's just get into that immediately. And we're going to do that according to the following agenda. So first of all, we're going to talk to you a bit through this innovation funnel that we're talking about the theory, but also some practice. Then we're going to talk a bit about simulation and A/B experimenting. You will see that we actually use both, and we want to talk to you a bit about why we use both. Then about failures and successes, just a bit in practice, what did we see using this funnel, and how did it go? And eventually we're going to wrap up.
So the innovation funnel, so we named it a couple of times. So first we want to guide you briefly through this funnel, and then next up we will go into more detail to all the steps. So first step, similar to the typical innovation funnel we discussed, is we always start with a problem or an opportunity, or we found a way to create value. So what we would do so in the typical innovation funnel is we have a problem, and the next step, dive directly into a solution. But what we do first as a second step is we define a KPI. And this KPI should say something about the success of our solution, so about the success of our innovation. And once we have a KPI, then we go to the third step. And then we're actually thinking about multiple solutions to solve the problem. And the fourth step is important and different from what we used to do, because normally you create a long list of ideas and you select one that you believe it's most promising, and you're building that. And what we do in the innovation funnel is we select maybe multiple ideas, so maybe multiple solutions that are working, and we build MVPs of them. An MVP is just a small, minimal viable product. It's a small version. It could be simple, so it does not need to have all unit tests, all logging, all details. It doesn't need to have a handle all edge cases. So we built one or multiple MVPs. And as a fifth step, we test them in a simulation. Later, we will go into more detail about how we exactly do that. But after testing them in a simulation, there could be two results. One result is that one of the ideas is actually better than the version that's currently in production. So then we go to the next step in our innovation funnel. But it could also be that all our ideas are even worse than, according to our KPI, than what's running in production. And in that case, then of course we need to go back to the solution design and improve our ideas. But if it survives the simulation test, then we go to the next step, which is building. We had already a simple version, but to put it in production, we need a more detailed version. So we need to add the test, we need to add the loggings, and then finally we can, it's production ready. And then still we would like to run an A/B test before even, say it's done. So then we run an A/B test, and once after the A/B test, we find out that our idea is better than what we currently having on production. Then we deploy, and then we of course celebrate the success because we brought a new innovation live. And so this is the innovation funnel very briefly through all steps. So now we'll go over all the steps in a bit more detail.
Yeah, indeed, a lot of theory. Let's go into practice, and let's take an example. So in my team, we create an algorithm that creates the picking routes, and this algorithm is called Pacman. So that's why you see this nice Pacman icon on this slide. And we create picking routes, and what it actually means is that we use stock and orders as an input, and we transform them into picking routes, which means are like items that we have to pick from certain location in a certain sequence. And each of these lists of picks that we need to do, that's a picking route. So last year, we picked 40 million items in our warehouse in only BFC1. And you can imagine that we can gain a lot because it costs a lot of money. Every pick takes quite a lot of seconds, and if you can reduce that, then you can save a lot of costs. So here's our opportunity. So we have our opportunity. Let's go further and let's define our KPI. And for us, our KPI is the time per pick, which means the seconds that it takes to pick a couple of items divided by the number of items. And you can probably imagine that if it takes less time per pick, then people have to work. We need to hire less people, so eventually we make money, right? So we have our KPI, and then we go further and we have solution designs. Now, I don't want to go too much into depth here. It's of course a very specific problem, but you can of course think of like a gazillion ways of improving that algorithm. You can think of adding picks that have a very low relative distance to each other. You can think of maybe creating zones within the warehouse or subzones and adding picks there. You can think of routing algorithms, all these sort of things. And what we tend to do is we take sort of a theme of ideas of how to improve this algorithm. And within that theme, we think of a couple of solutions how to do that. And eventually we come up with, for example, 3 ideas how we can improve that. We start building MVPs, and for us, an MVP would be then actually a deployed algorithm in the cloud where there's no traffic yet going through in production, but it is already being deployed. And of course, this also, as Christianne says, doesn't have to be a doesn't have to handle all edge cases, doesn't have to do all the unit testing already. It can be a bit quick and dirty, but it should be already deployed in a pod, and I will tell you later why that is. So next step, simulation.
Yeah, so simulation. So we have some ideas, we have some MVPs, and now we need to test them. And how are we going to do this? How are we going to simulate those ideas? So how does our general process looks like? So we have input goes into our service, and we have output that comes out of a service. But that's not directly our KPI, because normally we send this output to, or in Loek's case, to the warehouse, and then operators in the warehouse are going to pick, and we create the KPI, time per pick. But we also have, so there is an operations in between. So in simulation, we make use of this process. So we have 2 variants. We have one control variant, which is the variant that's actually running into production. And we have one or more, depends on the number of MVPs we would like to test, one or more treatment variants. So what's happening? So we have input. Input goes into our service. We create output. And then we need something to translate this output into our KPI. And this something is, in our case, a model of operations. So we're creating a model that's doing that translation for us. And then, as I said, we also have a second variant. So that's treatment. And treatment's the exact same. So we have input, we have our service, which is the minimal viable product that, for example, Loek's team also created. And we have output, which is mainly different from the control variant. We use the same model to generate a KPI. And of course, most important step here is that we compare the KPI of the control with the treatment. And we see if it's actually higher or if we're doing a better job in the treatment. And if so, if we're happy, we go to the next step in our funnel. If not, we might go back to the solution design.
Yeah, so again, a lot of theory. Let's see how this works in practice. And let's go back to our example, our picking routes. So what we actually did in our team is we created a Python package which allows us to do this simulation. We call it a simulation framework, and you can actually see it sort of as an API to very easily communicate with all our resources in the cloud. So how would that then work? So this is actually how we would run a simulation for a new possible innovation. We collect some data. We collect some input data, and as you see, we collect it from let's say last week we collect data. Think of input like the orders that have been there last week, but also the stock that we need. And once we run this, then on the background we will collect some data from BigQuery and from storage buckets, and then we have our input data. Secondly, we need to create some variants, different variants which link towards those pods that we have deployed in the cloud. So each of these pods links to one of our pods. Each of these variants links to one of these pods. And we put them together in an experiment, as we call it. We combine them into, so we combine the input and the variants. We call the run method, the run simulation method. And with this, we're calling this running simulation method, we call to, we bring all our input towards the pods in the cloud, and we generate output. And then we have our output for our simulation. And you can imagine that maybe this is a one-time cost, which costs a lot of development time to create this framework. But once you have this, you can run a lot of simulations through it. So it might be worth to do this. So we have our output, but our output isn't yet the KPI, right? So the output for us looks something like this. We have a distance that needs to be a distance for each route. And we have a couple of products that we need to pick from certain locations. How do we translate this into our KPI, time per pick? And we do that by a model of our operations. And for us, our model is something like this. So you can imagine that if you walk a route, then maybe you first of all have some startup time. Let's call it, and let's say that takes beta 0 seconds, some sort of parameter times the amount of seconds. For each pick, we need some time. We need some time to find the stuff from the shelves. We need to some time to scan it, so that also takes a bit of time. And each traveled meter also takes some time. If we have these three parameters, we can fit a linear regression model to calculate the time per pick. And voila, suddenly we have a model of our operations. And in this case, we can, for example, find that our third algorithm that we created is the best one, and that's the lowest time per pick. So we continue with that one.
And I see you all wondering, simulation, really cool, good example of the team of Loek. But does it also work in my environment? So is this applicable in my team? And to give you some examples, it's not always true. It's not always applicable in your team. So let's say we're working with the team on a pricing model. So for each item, we need to come up with a price. Can we use simulation in that case? And we think that if you create a price, so let's say that's what your algorithm is doing, and your KPI is conversion rate, then you might very well create a model that's translating price to a conversion rate. I think in high school you might learn something about price elasticity. So there are a lot of reasons of ways to do so. So if this is your case, then simulation might be the way to go. But there are also other cases. So let's say you're working on the web shop and you change the color of a banner on the web shop. And by doing so, your output of your service is the color. And your KPI is, for example, again, conversion rate. So then you need a model that's translating the color of a banner to the conversion rate. And how are we going to do that? Like, I would say, I myself would have no clue. So in this case, I would say simulation is maybe not the way to go, and you just need an A/B test to test this. So yeah, check if this works in your team as well. And if it does, then yeah, simulation could be very useful. And if you would like to do that, then we basically need 3 things. So to wrap it up, firstly, we need a KPI, as Loek discussed. Then we need a simulation framework. So it's a one-time investment to run the simulations. And thirdly, we need a model of operations so that we can translate the output of our services into the KPI.
Cool. So we did our simulation. Let's start building. And so we found one variant which is the best. Let's start building. And with let's start building, I actually mean that often our software engineers start building, because let's face it, this is not like the strongest point for us as data scientists. But yeah, it's a team effort. So we start building. We have built it suddenly, and then we can continue with the A/B testing. And I think maybe a lot of you already know A/B testing. Well, eventually it's sort of similar as how it would work in our simulation. We get input, it goes through to a control, either a control or a treatment service. They generate output, they run through the operations, but now suddenly the operations are actually running. It's actually running in production. Because it's running on production, KPIs are generated, and we can then compare our treatment versus our control variant. 2 things that we need to do here. First of all, is inputs. You need to be able to split your traffic. This time suddenly we cannot use the input for both the services. And we need to be able to track our variance. We need to be able to know, hey, I measured this KPI and that's generated by this service, by the control algorithm or the treatment algorithm. So A/B testing, if you want to do it, of course, there's a lot more to it, but in a sense, we need a KPI to define the success of an innovation again. We need to be able to split traffic, so you need to sort of somehow incorporate that in your IT landscape. And you need to be able to track and measure your variance.
So a lot of information, but luckily we made it through the whole innovation funnel, so through all the steps. And we mentioned 2 types of validation. So we said simulation, and we said A/B testing. And why are we actually doing those 2 kinds of validation? So why not only simulation? Why not only using an A/B test? Why do we need both? It takes time, right, to develop. And I would like to explain that to you with the following framework. So we have the real world, which is the world that's actually running into production. And we have our control variant, so that's what's currently running into production. And we have our treatment variant, so that would be the version that we would like to have running in production. And what if we only do an A/B test? Then there might be 2 problems or 2 things that we could have avoided. And one thing is, it takes time. So it takes quite some time to create the treatment variant of the real world because it needs to have all details. It takes quite some IT time to build it. And secondly, it takes time to run the experiment. Like you need to wait for data coming into your production environment, and you need to run the experiment for quite some time. So yeah, if we find out that the treatment variant is not as good as we thought, we lost a lot of time here. So what we're trying is to avoid that. And therefore we're using simulation. So with simulation, we're creating, as explained, the simple version. So it doesn't take a lot of time to build that version because it doesn't need to have all details. And we also do not have to wait for all the traffic coming into our production environment because we can just use historical data and run it. So we have our control and treatment again. We can compare them. We can find out if in simulation the treatment variant is doing better than the control variant. And we could also say, we're not only using A/B test, why not only using simulation? So then at this point, if you find that the treatment variant is better, just put it into production and celebrate. This is also not the best idea because there's always a bias between the real world and your model because of all the simplifications you did. So if this delta or this bias between the two, that bias can cause that maybe your idea is good in simulation, but not in production. So therefore, we still need to use an A/B test to check if it runs in here. But we could already have failed fast after we did the simulation. So to wrap this whole idea up, some benefits and some benefits of simulation and some benefits of A/B tests. So for simulation, we use the same input for both variants, so we do not have to split our traffic. Another benefit is that an MVP, so a simple version, is sufficient. We can validate really fast. We do not have to wait for data coming in. And there's no impact on the production environment, because if you would run it in production, your A/B test, and you find out that the ID was not that good as you thought, then you could also lose a lot of money, right? Because half of your traffic saw the treatment variant. There are also some benefits of A/B tests, because there are no assumption. There's no simplification of the model. So therefore, there's also no bias between the model and the real world. So therefore, we would say, let's also try an A/B test as well.
Yeah. So Christianne has stressed the fact that we need both. We need simulation and A/B testing. And I want to show that again with an example. Actually, a couple of examples. So in our team, we did a couple of innovations in the past, and one of them was just some parameter settings in our algorithm. We have quite a lot of parameter settings, and we know that these parameters, setting them, it changes our KPI eventually, so it changes the performance of our algorithm. But we don't know exactly how. So what we would do in the past sometimes, if we would run a lot, we would sometimes just change this parameter and see what actually happens in the real world with an A/B experiment, for example. But you can maybe realize that this can cost a lot of time, and also sometimes you have settings which are not that good. So maybe if you would have run in a simulation, you would have already found that some of these settings are really a bad idea, and you can just stop it after the simulation. So this really helped us save a lot of time. Secondly, another innovation, cherry picking. It was an innovation we did like a year ago. We did a simulation and we found, we thought that the cost savings would be huge, about 1 million euros cost saving we expected from cherry picking. So we thought, okay, let's do it, and let's run it in an A/B experiment. And we ran the A/B experiment, and we found out that we would really not make that business case of 1 million. We were actually even, it was just worse than the control variant. And we found out that our simulation just had a lot of assumptions that actually didn't apply in the real world. And we were very happy actually that we did an A/B experiment, because otherwise we would have really just run in production if we would have only done a simulation. So very important to still do the A/B experiments. And lastly, a couple of months ago, we finished a project which was initiated by one of our interns called Flexible Zoning. And there, our interns made a couple of different algorithms, like 5 or something. She tested all. Some were very good, some were a bit worse. So from the simulation, we found that one was the best. We did an A/B experiment and it passed, and it was really a good innovation, and we probably saved saved like more than 200,000 euros on it. So this was really good.
So some nice examples, and if you think that this would also happen, this would also be very beneficial for your team. You have a small checklist of things that we can that you need. So first, we need a KPI. And secondly, for the simulation, we need a simulation framework, and we need a model of operations. And for the A/B test, we also need 2 things. So one is we need to split the traffic. And secondly, we need to track and measure all the different variants. So we totally understand that even if this might be a great idea for your team, you're not going to start building it tomorrow, because there's quite some investment in building the framework, etc. So, but what we do think is very important, that if somebody is coming to you and says, hey, I've got a great idea, we can do this innovation and we can save €500,000 by doing so, that we do not directly think, oh, that's a lot of money. We can actually build, as Loek mentioned, that pool of money in our backyards. Let's do it, let's build it. But know that you ask yourself the question more often, like, can we validate this business case? So can we do that before going to production so we can fail fast? Or if possible, after our production, after going to production, if that's possible. And if we ask ourselves this question more often, then we really hope that we could eventually have that big pool of money in our backyards.
Thank you very much.
Thank you.
Thank you, Loek and Christianne, for a great story. But you have a question that came in. So
Nice.
yes, you hear a voiceover now, everyone at home. You don't see me. I'm looking at Loek and Christianne. So I'm not a ghost somewhere. But we have a question that's actually from Isaac. He put his name in there. That's nice. Did you validate your simulator against the real world with A/B tests? Is the change directionally good? Positive correlation between the two, and can you quantify the differences?
Okay. Yeah. So we actually did run an sort of an AA test. Yeah. So what we did is we took the actual results from the past. Let's say. We took the actual results from the past and we ran our simulation against that, and we started seeing if. We saw some small differences, but that was all quite relative. And the thing is, you still have sort of a safety net, right? You still always have this A/B experimenting. So yeah, we validated it and we thought it was good enough. But eventually, with the A/B experiments, you can always still see if it was good enough.
Right. Thank you for the answer. I hope Isaac is happy with it as well.
I hope so too.
Cannot see his reaction right now, but I'm sure he will. I had no more other questions. If there is still discussion going on, it is of course in the Google thread, so you guys can also join.
Awesome.
If people have other questions.
Great.
Thank you again. Good
Thank
that you are in the studio. Nice to have you guys on the Space Summit conference.
Cool. Thanks.
Thank you.